Advanced Algebra 2, Notes, Graphing Radical Functions. This is Concept 20. So we're going to be focusing on square root and cube root functions. The first thing you want to do is to become familiar with the parent square root and the parent cube root functions. So if you look at this chart on your notes packet, look on the left-hand column. So the parent function for the family of the square root function is f of x equals the square root of x. Notice we don't have any numbers in that function except for 1 and 0. Also, notice the graph of that. See how this graph has a definite starting point. So it begins at the origin, and then it goes up and to the right. So it's only in the upper first quadrant. Now let's talk about the domain of this graph. And to do that, you're going to look at where the curve is and compared to the x-axis. So if you run your eyes along the x-axis, you can see the curve above the x values that are greater than and equal to 0. Let's do the same for the range. So run your eyes along the y-axis and see where the curve is. Notice that the curve of the square root is across from the y values that are 0 and positive. So the domain and range of a square root function is limited. And this is the parent square root function, to x is greater than 0 and y is greater than 0. Now let's look at the cube root function. So this is the parent function for the family of cube root functions. F of x equals the cube root of x. Run your eyes along the x-axis and notice that you can see the curve above and below all of the x values from negative to 0 to positive. So the domain of the cube root function is all real numbers. Do this with the range as well. If we were to continue this curve, we would see that it is across all the y values, so where the y values are negative, 0, and positive. The reason why the domain and range of the graphs are limited is because of the math that's happening in the functions. So notice down below in the bottom of this graphic here, the domain of the square root is restricted and the range is restricted also. Notice that the domain and the range of the cube root function is not. Why is that? Well, it is because the even root of a negative number, as you know, is not a real number. That's an imaginary number. And so that is not anything that we could graph. With a cube root function, however, we can take the cube root or any odd root of a positive, 0, or negative. So odd roots don't have limitations, because if you take the odd root of a negative number or 0 or positive, you will get a real number output. Guess what? Square and cube root functions are transformed by the a, h, and k values in the same way that the other functions that we have studied are transformed. Absolute value, quadratic, those. We haven't covered exponential and logarithmic yet, but we will. Now look at these general functions. So f of x equals, notice this is square root, and notice where the a, h, and k values fall. So a is our multiplier out front, h is the number that's added or subtracted underneath the radical by the x, and the k value is out to the end. Now with our f of x equals cube root, notice the a, h, and k values are in the same position. So let's complete a table of transformations with our radical functions, focusing on square root and cube root. So let's start with an example. A horizontal translation, that means the graph shifts left or right. Just as in other functions, you will have an h value other than 0 that's introduced. So let's say g of x equals the square root of x minus 2. So our h value is 2, so that is shifting our graph 2 to the right. So normally our domain and range are both x and y are greater than or equal to 0. But because we are shifting off the origin, that's going to adjust our domain. So now our domain will be different, and we'll get back to that in a minute. Now let's look at another example. So let's do a cube root. G of x equals the cube root of x plus 3. We have an h value now of negative 3, so that means our graph is shifting through the 3 to the left. As I'm sure you recognize, you know how these how the h value affects the graph of a function. Now let's talk about domain and range. So as I was saying, with the square root, that's going to adjust our domain, so shift it 2 to the right. We are not shifting up or down, so our y value is unaffected. And then with the cube root function, it does not matter how we shift it. Our domain and range are still all real numbers. Let's look at vertical translation. So this will be the k value. So let's do a square root example. G of x equals the square root of x plus 7. And of course, that's going to move our graph 7 up. Our domain will not be affected. However, our range will, because that graph is shifting 7 up. That means that it will start where y is greater than or equal to 7. I said 7 up. Did you hear me? All right, now let's look at another example. So let's do a cube root. We have the cube root of x minus 1. So that will shift it 1 down. And again, our domain and range, because it's a cube root, will not be affected. Let's talk about reflections. So if we have the negative on the inside, that of course will be a y-axis reflection, and on the inside of the radical, it's only affecting the x. How it will affect our domain is that that is going to reflect it across the y-axis. So the x's that will be used in graphing are the ones that are now less than or equal to 0, but our range will be unaffected. And now for a x-axis reflection, of course the negative will be out front. And an x-axis reflection means it's going to be flipped over the x-axis. So our domain is unaffected, but our range is. It will be all the values that are less than or equal to 0. Now let's look at vertical stretches or shrinks. And remember, we can also call that a compress. This will be the a value. And so this is where the graph stretches away from the y-axis or shrinks toward the x-axis. So g of x equals 4 times the square root of x. So our a value is outside the radical, so that would be a vertical stretch by 4. And it's not affecting, it doesn't shift the graph off of the origin, so it doesn't affect the domain and range from the parent function. They are both greater than or equal to 0. Now for a vertical shrink, that number out front, the value of it will be less than 1. So this is a vertical shrink or compress by 1/5. And again, it's not going to affect our domain and range. Now let's talk about horizontal stretches or shrinks. This is when our a value is actually inside the radical. So an example would be g of x equals the square root of 3x. So remember, this is opposite of what you would think. This is an actual horizontal shrink by 1/3. It is not going to affect our domain or range. It won't shift it off the origin. It's just going to shrink it away from the x-axis. And then I can do I'm still going to use a square root function here. And so I have the square root of 1/2 x. That is a horizontal stretch by 2. So remember with the horizontal stretches or shrinks that the multiplier is opposite of what you would think. And the graph is going to stretch away or towards that the y-axis. Or I think I mean to say x-axis there. All right, now let's graph the parent function of the square root and the cube root. So we're just going to put values in for y equals the square root of x. And I'm going to use numbers that are, just make it easy on myself. So I'm going to start with 0 because I know that's the beginning of this graph. Square root of 0 is 0. And then I'm going to put in perfect square values, and they do need to be positive, so I have real numbers. So square root of 1 is 1, square root of 4 is 2, and the square root of 9 is 3. So again, I'm choosing those values for x so that my y values are even numbers, just making it easy on myself. Now I'm going to draw my xy axis and just shift it over and down a little so I have lots of positive space. As I graph those points, remember that I have a starting point. So I'm not going to extend to the left through 0, 0 because those points are that part of the curve doesn't exist. So I start at 0, 0, and then the curve goes gradually up and to the right. Now we can clearly see our domain. It's all the values that are at 0 and greater than 0, and then the range also starts at 0 and uses all the y values that are greater than or equal to 0. Now the cube root function is a little different. So we're going to plug in values for x. 0, 0 will be my middle point, so the cube root of 0 is 0, and then I'm going to do negative and positive numbers that are perfect cubes. So -1 and -8. The cube root of -8 is -2, the cube root of -1 is -1, and the cube root of 1 is 1, and the cube root of 8 is 2. I'm going to put my xy axis right in the center and then plot these points. Now this, the way this curve goes is I like to think of it like an old-time propeller on an airplane. It does a little jig-jog in the middle. It will gradually, on the left side, and remember this is the parent function, drop down gradually and to the left, and then in the right it will increase gradually. Our domain is going to be the x values that are used will be all of the x values, the real number x values, and then the same for the y. There's no limitation there. All right, let's describe and graph the transformation of the parent square root and cube root functions now. So we're going to start with square root. So the process is, first of all, figure out the transformation. Then you're going to rewrite the function without the h and k values. You'll make a table of values and then add or subtract those h and k values to the x and y. So this is just an easy way to do the shift in the table rather than having two graphs, an original graph and then one graph that is shifted. So here's what it looks like. All right, so in 1a we have g of x equals x minus 3 plus 4. Notice our h value is positive 3. So that's a shift 3 to the right, and our k value is 4, and that's a shift 4 up. So this function, without those h and k values, will be just y equals the square root of x. Then I'm going to do the shift just to the x and the y values. So since I'm shifting 3 to the right, I'm going to add 3 to all my x values, and then we'll add 4 eventually to my y values. First, I just start, though, with putting x values into the function without the h and k. So when I plug in 0 into just the square root of x, plug in 0 for x, I get 0, 1 I get 1, 4 I get 2, and 9 I get 3. Now I'm going to shift my x values 3 to the right just by adding 3, and I'm going to do that in red. And then I'm going to shift my y values 4 up. So see, we're doing the shift in the table. So we'll just have one graph, and the graph will be of the transformed function. So I'm giving myself lots of positive space to graph this, and as I graph it, I have a starting point at 3, 4. So my domain has adjusted. Now it's all the x values that are greater than or equal to 3, and my range has shifted as well. It's all the y values that are greater than or equal to 4. All right, now in this part of the notes, let's just do one more example. So 1b. Notice we have g of x equals the square root of 1/4 x. So what we have here is a horizontal stretch by 4. So that's going to stretch our graph away from our x-axis. We do not have any h or k values to ignore, so we're going to plug values into this equation. So if I plug in 0, I just get the square root of 1/4 times 0 is 0. If I plug in 1, the square root of 1/4 is a half. If I plug in 4, the square root of 1 is 1. And then if I plug in 9, I get 9/4, and the square root of 9/4 is 3 halves. So I'm going to draw my xy axis and then plot these points. So notice that this horizontal stretch, it's going to stretch it, and I believe I said towards, away, but I meant towards. It's going to stretch it towards the x-axis, away from the y-axis. Our domain and range have not shifted, though, from the parent. We still have all the x values that are greater than or equal to 0 that are being used to create this curve, and all the y values that are also greater than or equal to 0 to create this curve. All right, that concludes our part 1 notes. We're going to continue with some cube root function graphing and then just making some transformations with equations.